You start off with one amoeba. Every minute, this amoeba can either die, do nothing, split into two, or split into three amoebas, all these scenarios being equally likely to happen. All further amoebas behave the same way. What is the probability that the amoebas eventually die off? If you want to try the problem yourself, pause the video here and come back when you have an answer. I'll go ahead and reveal the solution now. Let's denote P as the probability that a single amoeba will eventually die off. If we have two amoebas, the probability that both will eventually die off is just P squared, since these amoebas behave independently. Therefore, if we have n amoebas, the probability that all of them will eventually die off is just P to the power of n. Using this information, we can write an expression for P in terms of itself. Since we want to know the probability that one single amoeba will eventually die off, our expression is P is equal to 1/4 times 1 plus 1/4 times P plus 1/4 times P squared plus 1/4 times P to the third, denoting each of the four possible scenarios. Let's multiply both sides by 4, at which point we'll get 4P is equal to 1 plus P squared and plus P to the third. Then we'll subtract 4P from both sides to get 1 minus 3P plus P squared plus P to the third is equal to 0. Since this is a polynomial of degree 3, we'll likely get more than one value for P, but we'll see that only one of them will really make sense. Now let's try to divide this expression by P minus 1. Using long division, we'll get P squared plus 2P minus 1, which means that P minus 1 times P squared plus 2P minus 1 is equal to 0. This means that either the expression P minus 1 must be 0, or the expression P squared plus 2P minus 1 must be 0. In the first case, we can conclude that P is equal to 1, and in the second case, we can use the quadratic formula to figure out the other two roots of this expression. The quadratic formula gives us two roots, square root of 2 minus 1, and negative square root of 2 minus 1. Now clearly, negative square root of 2 minus 1 cannot be P, since it's negative, and so we're left with square root of 2 minus 1 and 1. So technically, both values are possible, and it's not necessarily clear which one is correct. Now, there's a rigorous way to arrive at the answer and a less rigorous one. The complete proof uses the fact that P is increasing in time, meaning that the longer the experiment goes on, the greater the probability that all the amoebas have already died out, and then uses this fact to arrive at an upper bound for P that's actually lower than 1. But the less rigorous way, we can observe that it would make very little sense for P to be 1, since in half the cases the amoeba splits into 2 or even 3, so the probability that the amoebas survive should be greater than 0. Thus, since P represents the probability that the amoebas eventually die off, P should be less than 1. There's even a theorem of branching processes that if the mean number of offsprings produced is greater than 1, then the correct probability of extinction is always the smallest positive root, which in this case is the square root of 2 minus 1. In our case, the mean number of offsprings produced by a single amoeba is 3/2, which is greater than 1. So the correct answer for P is in fact the square root of 2 minus 1. Okay, so I hope you enjoyed this problem, and I'll hope to see you again next time.